Hi, we're Group Bubble Tea. Our presentation contains 4 parts. The first is introduction and brief literature review. Then we do the modeling for COVID-19 daily new cases and unemployment. Finally, is a conclusion. This project is useful for the government to develop policies to control the pandemic and stimulate economic development. ARIMA-GACH model is our core model. Current research already develops a number of models to forecast them, although some was done using advanced machine learning methods. Traditional ARMA model is shown to be useful. They find ARMA outperformed other models for new cases prediction, including exponential smoothing and QV-SPI. In forecasting unemployment, ARMA is also used widely. First, we look at the daily new cases for Singapore. The raw data shows a peak from April to August last year and stationary at other time. So we perform the transformation of taking the natural logarithm and first difference. The second plot shows how transform data looks stationary and volatility clustering is observed. To identify suitable models for this transform series, we look at its ACF and PACF. It is clear the autocorrelation is only significant at leg 2, and PACF shows an oscillating pattern. An MA model may be used. The ACF obscures theory shows significant heteroscedasticity. Other explanatory variables in the raw data set seem not significant, so we use OM data only. Based on analysis before, we propose 2 models, ARMA01-1 and ARMA01-1-1. We find the AIC and BIC for the GACH model is smaller. Diagnostic checking shows the 2 models are adequate, but ARCH is worse than GACH in cleaning up heteroscedasticity, so we think GACH should be the better one in terms of model adequacy. Then we come to validation. The 2 models show very similar and satisfactory performance. We can see the predicted value, which is the red line, tracks the actual value closely. Also, 2 models have similar MSE. The difference is negligible. Then we sum up the daily predictions to monthly prediction, and we have this table. Considering both the model adequacy and validation result, we select ARMA01-1-1 as the final model. The final step is to make the prediction for October. Transforming to original data, predicted value shows a slightly increasing trend. Summing up the daily predictions, we get the prediction for October, which is 80,831.
Next, I will introduce the process of analyzing the daily new cases of the United States. Data characteristics of the daily new cases of the United States is quite different from Singapore. We can easily find that the raw data shows a peak from November 2020 to January 2021, fluctuated widely most of the time. If we think deeply about the reasons for the surge, perhaps it is the large gatherings during the US election campaign that leads to the rapid increase of daily new cases. To fit a suitable time series model, we can process the data with the same method of Singapore. To further determine the model, ACF and PACF graphs are shown on screen. It is difficult to determine the model only by observing the plots. So we use the AutoRIMA function to preliminarily determine the model parameters. Then we adjust it according to the degree of model fitting. After a large number of parameter adjustment, we finally determine the ARMA17 model, whose p-value in the rescue test is 0.8995. It is obvious that there exists a significant heteroscedasticity, which means an ARCH or GACH model should be included. Just like the analysis of Singapore, we have also established 2 models for comparison. For model validation, from June 2021 to September 2021, 2 models still show very similar and satisfactory performance, which means both models are appropriate. Considering both model adequacy and validation result, we select GACH as the final model. So the final model can be expressed as what is shown on the screen. Summing up the daily predictions, we get a prediction for October 2021. On average, 146,438 per day. That's all for US daily new cases.
Next, I will introduce the UK model. We can see the original data in the left picture. The daily new cases peak from December 2020 to January 2021, and it fluctuated most of the time, having the uptrend. Because it is not stationary, we take the log and the first difference. After that, we get stationary but volatility clustering data. Then the ACF plot shows that data significant at long 1 and insignificant at other time. For the PACF plot, it shows significant at first 3 legs. Then we use auto-ARIMA function to select model. According to the ArchLM test, we decided to use ARMA-GARCH model to fit the data. According to the previous selection and the test, the ARMA12 GARCH11 has a higher p-value for box test than ARMA-ARCH model. So we use the ARMA-GARCH as our final model. The results are shown in the right chart. We can see that the 2 models are same. So for the model prediction, we get month 10 prediction is 717,535. Transforming to original data, predict value continues to show a significant downward trend. Summing up the Singapore, the US, and the UK daily new cases, we get the global daily new cases.
So let me continue to introduce the models to predict monthly unemployment rate. We can see from the graph that the monthly unemployment rates follow the same trend that it increases and gradually go down. And also, I want to introduce some initialism like this. The basic source of our modeling is to use linear regression or just use SES method to fit the monthly data. Here, as the pandemic itself is an accident and the fluctuation will not have a long-term influence on the future, the more close to the present, the more influence it will affect the future. This coincidences with the features of SES. And for the data of UK, I found from the covariance that MUR is related to other parameters. So I computed the linear regression equation and then used the AIC function to eliminate the collinearity. Afterwards, I transformed the GRI and SI data by doing first order difference. After examining the stationarity and the residuals, I used ARMA11 and the GARCH11 model to fit the new data as then I used it to predict MUR for the next 122 days and compute the monthly MUR data for the next 4 months. Using the actual data, I computed the MAC of the module, which was nearly 1. Besides, according to the graph, I found that the MUR experienced a dramatic increase since the epidemic erupted, and such period is not going to be happen again. Therefore, I removed the gross data and fit the remaining data by ARIMA 010 model. So MAC is much lower. Finally, I tried SES method, so MAC is only around 0.02. Therefore, I used SES to do prediction. When it comes to the data of the United States, I just used the similar methods. Since the relationship between MUR and other parameters was not so significant, the results were not so satisfying. Therefore, I still choose SES method to predict the future MUR.
In this part, we moved to Singapore. We applied the ARMA-GARCH model and the exponential smoothing models to it. The result shows that the ARMA-GARCH model did not fit well with the real trend, but the exponential smooth method shows quite good performance. So we applied the residual test to it, and there's no auto regressions in the residues. We also calculate the mean square error values in these 2 models, indicates the same result that the exponential square shows a better performance. So decide to apply it to predict the value in October, and result is 2.5%. When it comes to global, we meet quite similar situations. The ARMA-GARCH model did not fit well, not only in the visual expectations, but also in the mean square error value test. So we also apply the mean exponential smoothing to predict data, and the result is 2.9%. Well, it comes to the conclusion that in the daily new cases, ARMA-GARCH model shows great compliance to the real daily new cases data. But when it comes to the monthly unemployment rates, the data shows different features in different countries. In the United Kingdom, we found the monthly unemployment rate is correlated with the government-related factors, so linear regressions shows better performance. But when it comes to Singapore, United States, and global, exponential smoothing indicates a better performance. And all in all, we try different models in different countries, in different situations, and we believe that we have found the best way to simulate the trends among the models we've tested before. And that's all of the report. Thank you for listening.